Thank you. That is. We'll wait for another 2 minutes before everyone joins. And then we can start the training for everyone. Thank you. Hello, everyone. Let us start the training session for heat pump basics today. My name is Mohammed Zishan. I'm the product manager for Ream Middle East. We are a manufacturing company, as you might know, that does air conditioning and water heating. Today, we are going to discuss about heat pumps and what are they? Are they something magical, or are they something to be easy to understand? It's a basic introduction today. We have a second training where we are going to talk about sizing, talk about the application, talk about how to design the systems, which will be considered as a little bit advanced. So this today's session will be a basic presentation on the product itself and how heat pumps works. I will take you through the slides, and if you have any questions, please keep your questions either in the chat or we can discuss at the end of the session. So let us start today's training. Firstly, we need to ask
Zishan, you're muted.
Zishan, you're mute.
The first question is, what is the problem and why are we here? Second, how can it be solved if there is a problem? Third, who can help solve this problem? Let us start with what is the problem. As you all are here from the industry of construction, either you're a consultant, client, contractor, or a supplier who are dealing with projects on a day to day basis, you already know what is the problem. The problems are our buildings. They contribute to 40% of the carbon dioxide emissions, which constitute to a larger volume of pollution. What does that mean? It means that if your buildings are consuming so much energy, you need to produce that energy from somewhere. And that somewhere comes from fossil fuels. So more energy is consumed, more energy is produced. And as we all know, what's happening across the world, how it is impacting our quality of life. There is air pollution, there is climate change. And if it continues and we don't act now, the future for our kids doesn't look that bright. So we'll have to do it for our future generation to leave a legacy of trying our best to inculcate sustainable solution. Let us try to understand this problem because that is the beginning. If we want to solve a problem, we need to know what is the problem and how can it be solved. So firstly, if you compare that to the energy usage inside a building, we have the highest energy consumed in the Middle East that goes to heating and cooling. That constitutes your ACs, your pumps, your water heaters. These are the major moving parts. Then you have lighting, then you have refrigeration, washing machines, other electronics. But the major chunk of the energy that's being consumed is your heating and cooling systems. How can it be solved? As you all are engineers, you're familiar with certain technologies. When it comes to ACs, you can use VRF technology or inverter technology that gives you an average energy saving of 25 to 30%. When it comes to pumps, you can use pumps with VFD that will give you typically about 30 to 40% savings. For water heating, what are you going to do? What is the possible solutions that is available? You guessed it right. That is heat pumps. Heat pumps is what's going to consume or save you energy. And how much is that savings? About 75%. So if you see the potential to save energy, the highest potential is in the heating or water heating itself, where you can save up to 75%. How do we save that? I will take you through in the coming slides, where I'll try to uh, make you understand a little bit more about heat pumps. Third question, who can help? So we are REAM. We are a 100-year-old company, which was started in 1925. We are a leading group of companies that has several brands that are familiar to you. We have more than 18,000 employees across the world, and our products are available across 85 countries, including all the GCC and some of the countries in Africa. We are one of the only manufacturers that does air, water, and refrigeration products. How can we help? What is our legacy of helping? So there are two parts to this slide. The first part is on the air conditioning, where Rheem specializes itself or boasts itself to be one of the major manufacturers. Our first AC units were produced in 1956. And then we have built our legacy over that. We have had our VRF products launched in 2023, and we also have some of our AC units that been launched last year. We have a brand called Rood in our portfolio. So if this is interesting, if you Google this name, you would probably find that Rood was inventor of automatic water heaters in 1889. So that's where our journey began. This company was taken over by remanufacturing in 1954. And that's how it's in our brand. That's how it's in this slide to showcase that it was invented by Rood. We were also the innovators of manufacturing or designing heat pumps in 1982. We launched our first hybrid heat pumps for residential in 2009. And then the products has evolved itself over the years. And here we are in 2025, where we have launched for our heat pumps in KSA market, as well as in 2024, we launched it for UAE market as well. 2023, sorry. These are our family of brands that we have it in the Ream group, Ream Manufacturing. There are so many familiar brands such as Ream, Rood, Richmond, Frederick, Paloma. These are some of the brands to name. Where are we based out of? So I'm sitting in the Dubai office of Ream. We have regional offices across GCC. If you want to connect with someone, you can reach out to me. I will connect you with our people across the region. So this is where I'm sitting in Dubai. We have our innovation centers where all our products are installed. These are in our in KSA and UAE. So in case anybody is interested to know more about our products, you're welcome. We can schedule a visit here. We have factories across the world, including one in UAE where we manufacture our package units for ACs. Let's deep dive into the residential heat pumps technology. The presentation is divided into two, mainly residential heat pumps as well as commercial heat pumps. I will touch base on both of the products and the solutions that is needed for projects. Now, how does the heat pumps works? As we all are, as most of the people are mechanical engineers, we have learned about the thermodynamic cycle of refrigeration. So heat pumps works exactly like that. Knowingly, unknowingly, we all have interacted with heat pumps. How? Everybody uses refrigerators, right? So you have refrigerators that does the cooling. So the backside of the refrigerator, if you go and touch, you will feel it's hot. So we are using the same technology to heat the water. And we're just inverting, instead of cooling, we are just heating the water. So how does that do? We have evaporators, we have compressors, we have condensers, we have throttling valves. Evaporator basically absorbs the energy from the ambient air and gives it to the refrigerant that it has. This makes energy of the refrigerant go up, which in turn increases slightly its pressure, changes its state, and also slightly its temperature. So the refrigerant then goes to the compressor, which is the heart of the system. So its job is to pump, right? So basically, it takes the energy from the air and pumps and increases its pressure and its temperature. This refrigerant then passes through evaporator coils or condenser coils. And this condenser coils basically is wrapped around the tanks. And this hot gas exchanges the temperature with the tanks. And inside the tank, there is water. The temperature increases over time. And then the refrigerant passes through the throttling valve, where it changes its state. And then again goes as a vapor liquid goes to the evaporator, and continues the cycle. So for each cycle, there is a delta T increase of water between 5 to 7 degrees. And then that 5 to 7 degrees gets transferred to the volume, and then the temperature increases. There is a controller, as you can see. That's the brain of the system. That's what is taking the readings from the sensors, monitoring the temperature of the tanks, and then instructing the compressors and all the system to work in cohesion. So that's how a typical heat pump system works. Now, someone can ask, where are all these parts? So all of these parts are inbuilt here. The exchanger is wrapped around this portion. So it's an integrated type of heat pumps where you have everything installed all together. There is no outdoor unit. It's all a single unit installed, and all you have to do is plug and play the pipes and the power. Now, what's the advantage of using a heat pump? Before I go into showing you how it works, let us understand how a COP, or a coefficient of performance, is calculated. Now, coefficient of performance is basically what is the energy that you're going to give into the water divided by what's the electricity it is getting consumed by the system. It's as simple as that. So let us compare that term with our traditional water heaters, right? Now we have 1 kilowatt of energy given into an electric water heater. We are only going to get 0.93 kilowatt of thermal energy into the heater. Why? Because heat pumps are electric water heaters are about 93 to 95% efficient. So they cannot transfer all the energy from electrical to heating, right? Then we have heat pumps on the other hand. When you give 1 kilowatt of energy to a heat pump, you're going to get an output of 4.2 kilowatt. So that's as good as savings of 75%. So this is how a heat pump works. You are getting almost 75% of energy savings for the same amount of electrical input given to a heater. How does that work? We'll take an in-depth look of critical components for us to understand each and every component of the heat pump. Firstly, evaporators. So evaporators are basically housing your refrigerants. They are the point of contact with the air from which the energy is absorbed. So hot air passes through the evaporators. This is how it looks. Evaporators are supposed to be with the hydrofilm coating. The advantage of that is that in case there is any moisture, it will slip down and it will increase the heat transfer. It is also protecting the tanks for a durable lifetime. The evaporator also encompasses high efficiency inner groove tubes that will increase the heat transfer as well. The second component is compressor. This is the actual heart of the system. So it's important that you need to have a reliable compressor that works 24/7 as and when the demand is there. Not only you need that, you need a compressor that vibrates less, creates less noise so that it provides comfort to the end users. You have condenser that does the heat exchange from the refrigerant. Condensers are of aluminum microchannel. The advantage of using this kind of condenser coils for heat pumps is that it increases the surface area, so you get higher heat transfer. So what differentiates different heat pumps that are available in the markets are all these kind of know-hows. Because ring manufacturing manufactures air conditioning, we have a fair bit of understanding on how the refrigeration cycle works. So we inculcate those ideas into our heat pumps in the water heaters as well. Also, an advantage of using such design is that there is no uh, mixing of refrigerant into the water itself. So that helps the end user. Then we have electronic expansion valve that has to be precise and that has to be automatic with electronic control so that an accurate flow rate and efficient reduction of refrigerant takes place. Refrigerant, if I have to compare that with our human body, that's the blood of the system. So you have different refrigerants available in the market. Our heat pumps are at R134A, which is one of the best refrigerants for hot water systems. It is having lower toxicity and low flame propagation. Then we have tanks. Tanks are the most important part of heat pumps. If your tanks are failing, then the water heater has to be replaced. So it's very important that tanks needs to be constructed. What kind of tanks? Mostly glass lined tanks or enamel tanks that has to be used so that you have a protection against the domestic water. The pressure of the tanks needs to be between 8 and 10 bar because this is what usually are the pressure ratings in the domestic side of the project. Now I discussed about the glass lining in the previous slides. Let me take you through how do you ensure that the
Sorry, one
glass
question.
lining for all the
Sorry for
questions.
interruption.
If you have any
At the
questions,
end.
sir,
Okay.
can you put it on the chat or we can have it
Okay.
after the
Okay.
session?
Noted. Okay. Okay.
Thank you, sir. So we have glass lining that is on the tanks. This is there to protect the steel itself. However, these are not completely um, clear coated, right? They have pores in it where the water can come in contact with the steel. You can't have a glass line that are completely covering the tanks because it becomes a brittle. So during transportation, there are chances that it will break, and in any case, it will start corrosion. So to protect those pores, what manufacturers traditionally do is that they create an artificial current in the form of magnesium anode. So they install this in the heater because the oxygen molecules then get attracted here rather than going to the tanks itself. And this is why within 6 months, you will see that the magnesium anode, which looks like this, starts getting consumed. However, there are new technologies now where you don't need to have consumable anodes. These anodes, in the traditional sense, you need to replace every 2 years. This is what every
Same.
manufacturer in the world.
هو بيتكلم عن البيزكس بتاع الهيت بامب عشان
Sorry, for we'll have the questions at the end of the session because we have to cover a lot of things, a lot of content in this. I kindly request everyone to ask their questions in the end session, or they can type in the chat box so that we can get back to you at the end of the session.
ولا نسمعها لو
بس لا اصلا انا داخل في النص.
So the powered anodes technically replaces the magnesium anodes. So you don't have to replace it every 2 years. Basically, this is providing you 24/7 round the clock protection and ensures that the tanks are protected all the time. So it's quite important to have powered anodes along with the magnesium anodes. So why we say that along? Sometimes in your sites, when we supply the water heaters, there might not be any electricity since the commissioning of the project. So to protect during that time, we will have a magnesium anode all the time. Also during any power cuts, which we thankfully don't see much in GCC, the tanks are protected all the time. So this is why it's important you have both the anodes, magnesium and the powered anodes inbuilt to protect the tanks. The controller, this is the brain of the system. It needs to have certain specification. It needs to have temperature indicators. It needs to have different modes of heating. And what do I mean by different modes? You have eco mode that could work only with heat pumps, electric mode that disables the heat pump and works as a normal electric water heater, and the quick mode that basically works in a sense of both electric as well as heat pump. You need to also have a timer function enabled on the system so end users can easily set the time of operation of the heat pumps. You don't have to physically do anything on the heat pumps itself. As we live in a digital world, need to also have an app to control that. Ream water heaters have an app that can Ream, Rood, Richmond, all of these brands of water heaters, we have an app that you can control, monitor the usage of the heat pumps, and that can help end users have a best experience of thermal comfort. It has several features similar to the controls that are on top of the heat pumps. In terms of the sizing of these heat pump water heaters, for a 2-bedroom and a 3-bedroom and a 4-bedroom and a 5-bedroom villas, you have different capacities to go for. For 2-bedroom, you can go with the 180-liter capacities. For a 3-bedroom, you can go about 280 liters. For a 4 and a 5, you can use multiples of the 280 liters, or you can go with the bigger units of 400 liters itself. That flexibility is provided by us. In terms of the height of the system, it's important to understand this part. It's very important so you can plan your pump rooms. It's one thing to know about the product. It's the other thing to actually use the product. So it's very, very important to imagine the height of the units. So for that matter, you have a 6 feet tall person right next to the heat pumps. So you can imagine the height of the heat pumps. The width is about 525 for 180 liters and 650 mm for 280 liters. This is mostly for 50 hertz markets. For 60 hertz for Saudi, it is slightly different. However, you can use the same data for planning your pump rooms. Typical installation. We have 3 drain connections. One to drain the tank, one drain connections on the TNP, and one more drain connections on the condensate drain. We have one inlet and one outlet that can be connected across the villa, across the residential apartments where the heat pumps are installed. In terms of the installation, for the freestanding models where you're not ducting, there needs to be certain clearances that you need to give. This is to ensure that there is proper air circulation. It is to ensure that the heat pumps, there is a delta T maintained between the air that is passing over the evaporators and air that is getting rejected by the evaporators, by the fans. So this is to ensure when it is freestanding, you need to have about 600 meter cube per hour of fresh air entering. In case you have any projects where it needs to be installed, where it needs to be designed, you can reach out to us and we can help you size the right design for the heat pumps. When it comes to ducted models, you can also duct the units. You have 50 hertz that you can duct the rejected air outside the room. So this gives you a bit of flexibility in reducing the room requirements and also to ensure that it can be installed in compact rooms. In 60 hertz models, you can do both the ducting of inlet as well as the outlet. So that can ensure easily the space constraints can be avoided. For the 50 hertz models, we have only the ducting at the discharge side. We have done several projects with this kind of design, and we've been very, very successful in such compact installation. In terms of the serviceability, the controller provides certain error codes, certain safety codes to ensure to know what might have gone wrong so that our technicians can easily rectify problems. There are several safety functions in the heat pumps itself which triggers such error codes, and some of the error codes such as HP trip, which is high pressure trip, low pressure trip. If there is a sensor which is faulty, it will also indicate that. So a lot of safety features incorporated within the heat pumps itself. There are different application scenarios. You can install these in garage, kitchen, pump rooms, uh, even in certain areas where can be with shaded areas. You can install it there. I will take you through the case study of the heat pumps itself. It's a comparison between electric and the heat pumps. When you replace an electric water heaters with the heat pump, this slide explains what is the impact. Firstly, on the left side, this is the total energy consumed by a heat pump, roughly about 667 watts. The output that the heat pump receives is about 2.8 kilowatt. When you calculate the energy for about 280 liter capacity and the time that is required to heat the water from 20 degrees to 60 degrees, it is about 4.64 hours in the ambient of 20 degrees roughly. So in 4.64 hours, your 667 watts of compressor heats 280 liters of water from 20 degrees to 60 degrees. Now, what's the total cost to produce such hot water? That's about 0.3 USD per day. Per year, that translates to 112 USD only. When it comes to electric water heater on the other side, it takes about 4.77 hours, typically same as your heat pump. However, the energy consumed is 3 kilowatt instead of 667 watts. So that reflects on the running cost as well. So the total running cost is 522 USD per year in comparison to 112 USD per year. That's a whopping savings of 78%. Roughly what I said the earlier slides, about 78%. So it makes a case for people to use less energy to save their money as well, and which improves their ROI on the investment they're going to do when they install a heat pump water heaters. Let's go to commercial water heater. This is the second part of our presentation. There are two types of commercial heat pump technologies currently available. The previous slides, in residential segment, there is only air to water heat pumps. The energy is taken from the air and transferred to the water. This is why air to water heat pumps. In commercial, you have also water to water heat pumps, which basically takes energy from the water from one side and transfers that to the water on the other side. There are different capacities that we have in air to water heat pumps. For 50 hertz, it's from 22 kilowatt to 248 kilowatt. And for Saudi, which is 60 hertz market, that is from 75 kilowatt till 213 kilowatt. In terms of water to water heat pump capacities, we have it from 71 kilowatt to 213 kilowatt, and 60 hertz is from 70 kilowatt to 280 kilowatt. Principle of working, I'm not going to explain about air to water. As I already explained in the previous slides, it remains the same. There is not much difference. Whereas in the water to water heat pumps, you have a heat exchanger instead of an evaporator coil. Basically, where this is installed in the pump rooms near to the chilled water plants. So you can connect your chilled water return at 12, 14 degrees. That goes into this heat pump, gives you a delta of 5 degrees. It loses 5 degrees and gives you back by 7 degrees and goes back to your chiller system. This 5 degrees to 7 degrees that is given out by this water is enough for the refrigerant to absorb, which then goes to the compressor, then goes to the condenser, then to the TXV. So that's how the refrigeration cycle works in water to water heat pumps. This is typically how we design a commercial heat pump system. Commercial heat pumps cannot work as it is. It needs to be with some storage. We are going to discuss more in detail about designs in the next training. So we would like to see all of you guys attending that as well. This is how a typical design looks like. You have storage water heaters or storage tanks that are connected to these heat pumps, and they are producing the hot water itself. We also have electric backup in case there is any sort of heat pumps not working. There are certain ambients, for example, our air to water heat pumps can work up to 52 degrees. But in case if 50 goes above 55, the heat pump will turn itself off, and then it will direct our heat electric backup to switch on. So this is how a typical system is designed with all the plumbing. This is a typical water to water heat pump layout, similar to air to water heat pump, except on the side of the chilled water, we have the pipings coming in from chilled water plant connected to the water to water heat pumps on one side, and the other side is connected to the tanks through these pipes. And all our commercial heat pumps come with the IQ control that has a controller inbuilt, which we will discuss in detail in the coming training. And we will explain to you how does that help in your systems. Let us go to the case study between the commercial heat pumps and the electric water heaters. So there are three modes of heating for a certain project. Let's assume the demand is for 10,000 liters. If I have to heat 10,000 liters, I would need roughly about 115 kilowatt of energy sized for a certain recovery time. Now, the same kind of energy I'm going to be used for air to water heat pumps as well as water to water heat pump as well. However, the difference is clearly contrast in the kilowatts that is being consumed. Electric water heaters will take up about 345 kilowatt of total load, whereas heat pumps take up about 124 kilowatt only. So to put things in perspective, when you look at big projects, big hotels, it's a huge cost for the hotel operators, for the clients. So it becomes a big case to use air to water or water to water heat pumps, depending on their requirement. This slide shows kilowatt hour required to produce per 10,000 liters of water heater.
Sorry to interrupt. Is that assuming a COP of 3 for these units?
Average,
Please?
yes. Average, yes. Average overall the year, throughout the year, yes. So we have total kilowatt hour that is required for 10,000 liters. We have central that is taking 372 kilowatt hour, whereas the heat pumps takes up about 100 kilowatt hour, and water to water takes up about 165 kilowatt hour. Now, people who see this usually ask me these questions: why water to water is only 55% compared to air to water? That's mostly because water to water during winter months, when there is not enough flow of chilled water, you have electric backups working all the time. So this is why you have your electric element consumption going up, and this is why the saving goes down, and this is how the systems operate. So out of three options, air to water is always the first priority. However, certain clients have requirements, don't have space, then they go for water to water heat pumps, which suits their requirement. Overall comparison between the electric tanks versus the heat pumps. We have already discussed about the energy saving. Product life cycle also matters a lot with the commercial systems for air to water and water to water having higher life cycle, giving a better ROI, maintenance cost being very low, operational cost being extremely low. So it all adds to the point where air to water and water to water heat pumps becomes an interesting proposition to use in the projects. Case study with the boilers. This is an overview of how the boiler systems are. You have the efficiency, which is about 90 to 95% efficient. However, the heat pumps are about 400 to 500% on a certain conditions. People who have worked with boilers, they know about the challenges they face, especially with the storage of the gas locally, along with the chimneys, which is a nightmare for architects. So it becomes a proposition for them to use air to water heat pump that doesn't provide such challenges. In terms of the initial cost comparison, boilers and the air to water heat pumps are almost similar. Whereas an operational cost wise, it's about 50 to 56% less. So it becomes an interesting proposition there as well, depending on which geography you are in. However, this is an average figure. What we have seen is that air to water heat pumps are really cheap in terms of the operational cost. In terms of maintenance cost as well, the air to water heat pumps are lower compared to the boilers. So now we have to the end of the session. If you have any questions, please you can ask one by one. We will try to take most of the questions. If not, then we will reach out to you, or we will reply to you on our email. I'll give you my contact details. You can write to me, and we will definitely be in touch to have any questions answered. Thank you.
Can I ask?
Yes.
Yeah, thank you for the presentation. I was going to ask about the microchannel aluminum. Why you didn't use it a copper fins in the residential one? Isn't it better for the condenser?
Yes. So aluminum microchannel gives us luxury of having a higher heat transfer, because we want to use the maximum energy. We want the maximum surface area for the tanks. When you have copper condenser coils, what it does is basically the surface contact on the tanks itself is not 100% because it is in the cylindrical shape. Whereas microchannel is flat, it basically helps us transfer heat better than the normal copper coils.
But in commercial, you use it copper, right?
In the commercial, we use a different type of technology. In commercial, what we have is heat exchanger itself, not the microchannel. In the residential, we have it wrapped around the tanks, whereas in commercial, we have shell and tube types. So it gives you a better surface area for heat transfer than the residential heat pumps.
Yeah, thank you. And one more question. Can you implement it with solar system, this heat pump?
Again, ma'am, can you repeat your question?
Can we have it integrated with solar system?
You can integrate the systems. You mean the commercial, right? We're talking about commercial.
Commercial, yeah.
Yes, of course. You can do the integration of the solar system as well. It is possible.
Yeah, thank you.
All right.
Which component is used in place of the evaporator in the water-to-water system?
Again?
Which component is used in place of an evaporator in the water-to-water system?
We use shell and tube heat exchangers that has refrigerant on one side and the water on the other side.
Assalamu alaikum, engineer. This is Engineer Ahmed from Al Mawraqi Company. Engineer, actually, I am wondering about the hybrid heat pump and the air-to-water heat pump. The hybrid heat pump, I can just inlet and outlet for the domestic water. It's okay. But for the air-to-water, I need calorifier or secondary loop for that. So why I cannot just make the air-to-water heat pump with high capacity just to for the domestic water? Why I need calorifier?
So calorifiers for commercial systems is needed because there is certain recovery time that we recommend for commercial heat pumps, right? So we cannot produce water from heat pumps instantaneously. It is not possible. No manufacturer can do that in the world. So for heat pumps, you need to have certain storage that you need to heat up to certain time. And that's what defines your heat pump's kilowatt. So this is why we have to have storage for commercial heat pumps, whereas when you have and the storage, of course, when we talk about thousands of liter, it is, you cannot just mount a commercial heat pumps on top of it. Whereas residential heat pumps, these are smaller capacities. Tanks can easily fit into certain pump rooms. It's easier to transport. So all of those challenges are mitigated, and we can do that in residential segment, whereas in commercial segment, it is not possible. So you need to have certain storage tanks to have it as a separate unit.
Hello, this is Ihab from Naga Architect.
Yes, hi.
Regarding you make the comparison for the residential range between the heat pump and the electric. So If you compare this residential range compared to solar system, which will be better? There is any comparison showing the performance? And
Yes.
okay.
Good question. Actually, compared to solar, heat pumps are again very good propositions because heat pumps can produce the energy throughout the year, right? Whereas solar, it cannot produce the energy during the night, number one, and during winters. So most of the times your electric backup is working, right? What we have seen is that in comparison to solar, our heat pumps would be saving roughly about 30 to 50% in the running cost. So, and not just that, right? I mean, you have certain control over your hot water system in compared to solar, which basically just works on its own. So operationally, heat pumps are a much better solution. People are looking into this as a very serious solution in terms of renewable energy. So and also in terms of the lower energy costs. So yeah, so heat pumps are much better than solar.
So do you have any value showing like the difference or the saving between both systems?
Yes, so it is roughly between 30 to 50%.
For the operation cost?
Yeah, for the operational cost, yes.
Okay. And what about the initial cost also? It can be the same or?
So initial cost, it is, of course, client have to invest slightly more than heat pumps. However, the ROIs on the heat pumps are 3 to 4 years. So the clients get that benefit out of that.
Okay. Okay. If you have this comparison, can you share it with us, please?
Yeah, we can share it across.
Okay, thank you.
Thank you.
I just was asking about the case study that been made. Is it made on real data, like based on real comparison, like heat pumps and air to water and water to water, or it is based a comparison with other brands in the market? So how this case study been made?
So the study was made for a 300-room hotel. We studied across the consumption. That was done basically for REAM, of course, for study purposes. What we have done is that the electric consumption, heat pump consumption for air to water and water to water was done in this study. The practical implications were that, during the winters mainly, that was for water to water, the heat pumps were not operating because of the low flow. And that's where we saw that the energy consumption was dipping and the element consumption was increasing.
So it was made on the same season, let's say, under
Yeah,
the
yeah.
same parameters and same circumstances.
So the study is a very detailed study. We can share it across to you. Basically, that's done throughout the year, taking into consideration all the ambient temperatures, the inlet temperatures, energy consumption, all of that, and the factors where your electric backups are working and the heat pumps are not working. So it's a very detailed study. We can share it with you.
Thank you.
I just have simply one question. I want to ask about the air change required, and does it depend on the capacity or not?
Again, sir, sorry.
My question is about the air change required, and does it depend on the capacity of the heat pump or not?
Yeah, the heat exchanger, right? You're talking about the heat exchanger.
Yes, of course.
Yes, on the commercial side, it would depend on the heat pumps. We have a certain rating conditions. We basically, every heat pump works on a different kilowatt, right? Throughout the different ambients or different water temperatures. So we have a certain selection criteria that we think, and then we use that selection criteria for the heat exchanger kilowatt. Based on that, you can select your heat exchanger kilowatt.
And for the residential one,
Hello. As for your information, the controller acts as the brain of the unit. Could you please
Sorry.
explain the safety standards or protocols followed by the preventive controller failure in applications?
Again, sir, can you repeat? Your voice was not clear.
As per your information, the controller acts as a brain of the unit. Could you
Correct.
please explain the safety standards and protocols typically followed to prevent the controller failure in applications?
Safety standards, you mean what we follow for our controllers, right?
Yeah.
Right. So our controllers are typically tested as per IEC standards, and what we provide is that our heat pumps are rigorously tested under every conditions, under different conditions of the ambient itself. It has certain inbuilt safety features that we have incorporated, such as high pressure refrigeration, high pressure, low pressure. In case there is any abnormal working of the water heater itself, there are certain safeties that gets triggered inside the controller itself. So there are certain list of controllers that certain list of safeties inside the controllers that we have incorporated.
Yeah, can I know one more? It is an piece. The controller was manufactured by using an PCB board. It is an waterproof or anything? The specialized boards.
Again, sir.
Yeah,
So
control.
Yeah, I'm here.
Yeah, tell me.
You can see it on the screen, the safety that is incorporated inside the heat pumps itself, right? These are all the safeties that they're incorporated inside the heat pumps.
So actually, what I have understood, your visibility is for visibility and identification of the failure of the controller. What I am asking, if the controller, I am asking physical. Actually, we are dealing with an heat pumps. The heat pumps was working with an water systems, right, for cooling and heating purpose. If any leakage occurs, means the controller, what was the preventive precautions we used for this controller? I'm asking.
Zishan Ansari, can I take up this question?
Yeah, please.
Hi. So I understand your question. So first of all, on the safety part of the PCB, all of our controls go through a rigorous ESD EMC testing. So that takes care of any safety related protection. The second, the controllers are mounted on a weatherproof panel. So it's completely waterproof, dustproof. So it takes care of any risk of PCB failures from external ingress of water or dust.
Yeah, okay, fine. Can you please share an safety standards? What was the used for that controller?
Sure.
Right. Yeah.
Yeah. Next question. We'll have another 2 questions. I'm sorry, we're running out of time. We will have another 2 questions, and then we can wrap up. I will share with you my contact details. So in case you have any doubts, you can reach out to me, and I will definitely help you with your questions.
Yes, I have a couple of questions, please. First of all, you know that the most critical part of the heat pump is the compressor. The compressor is a part where to have a failure, it is most common. So how many years of warranty you are giving for the compressor within the heat pump?
Sir, I'll let you answer that.
Sorry?
Yeah, so the compressor warranty depends on a lot of factors. So we can reach out to you separately based on whichever region you're placed on. The warranty keeps changing, but whichever region we can separately communicate with you the exact warranty.
Okay. Second question, you mentioned through your presentation that the GWP for it, it's around, I think, if I'm not mistaken, it's around 10,000. And you mentioned something regarding the COP. So for these both values, for the GWP, I'm sure it's not aligned with the STEDEMA, but what about the COP? Is this aligned with the STEDEMA for both? Because now, yes, please.
So you are asking the question that if the COPs are approved by STDAMA, is that the one?
Yes, because for the COP and the GWP are two important parameters for
Yeah.
Istidama.
Yes, so if you're using a heat pump, you are using a sustainable form of water heating, so it will be approved by STDOM. Yes, it is approved by STDOM.
Yeah, I know that the heat pump is considered as a renewable source of energy, but I'm
Yes.
specifically asking about the COP and the GWP.
COP and the last part was
GWP. You mentioned
GWP. Okay.
Yes, GWP. Yes.
Yes, hi, engineer. Yes, it would meet the requirements of Istidama in terms of COP, the coefficient of performance, including also the global warming requirements based on the refrigerant that is being implemented inside the heat pump. So as overall, yes, it will meet the requirements.
One last thing, okay. يعني, just double check this one because the GWP, يعني I think it's a little bit high. يعني. Anyway,
the GWB is not 10,000; it's 1,000 something. You know.
Okay, even 1,000 still high for GWP.
So what I would suggest, engineer, later on you can share it by email, and we can reply to you once you share us the requirements that particularly.
I will definitely. Yes.
Definitely.
I will share this one, and I will share regarding the warranty for the compressor. The last thing, please, regarding in terms of cost between the normal electric heaters and heat pumps. Considering you as a REAM manufacturing, you are manufacturing both. So if I have, for example, a villa and or apartment, and I'm going to use both in terms of cost, if I'm going to use multiple electric heaters compared to one heat pump to supply the whole thing.
Yeah, in terms of the price, as initially purchasing price between the heat pump and the electric water heater, the heat pump would be higher because we consider the heat pump as investment technology. By time, it will go to pay back for itself. And for specific requirements, we would prefer if you can share us that villa details, then we can prepare accurate comparison as feasibility study between the heat pump compared with the traditional water heater.
Okay, in your presentation, when you were talking about the residential heat pump, you mean for the villas only?
Now, definitely for villas, one of the applications that heat pump can be installed. Also for residential apartments, like residential towers, for larger apartments, also there is a feasibility for heat pumps to be replacing the electric water heater inside the apartments.
Yes, this is what I'm asking about because the size you mentioned for this residential heat pump, it's good for a villa where it will be placed inside a plant room or pump room, but for apartment, but apartment, even if you have like a laundry room or something, I think it will be still a little bit big. So only you have two sizes for the residential, as you mentioned, 180 and 280, correct?
Thank you, Mohandas, for pointing out an actual problem. So we are working on certain solutions right now for the apartments as well. Smaller capacities coming up from 80 liters, 110 and 150. We will update you once the product is released.
This is very important. This is actually very good. Yes.
This is something which we are working on, and we will update you in the future.
Yeah. Thank you so much. Thank you.
All right. I think we can take one more last question.
Hi. I have one different question. Hello?
Yes, sir.
Like, what is a suitable temperature for the hybrid system if it's installed in the indoor? For example, air conditioning space. Like now we discussed about the flat inside the installing the water heater, heat pump inside the apartments, right? For example, if I install the heat pump inside the apartment, so the discharge, like your operator will be above the false ceiling. So what is the suitable temperature like to get the efficient heating?
The best efficiency point, right?
Yes.
You're talking about.
So for example, our apartment above the false ceiling, the like normally air conditioning we used to calculate like 25 degrees Celsius, like above false ceiling. So will it work on that
yes
temperature?
Yes, it will work.
So if it's so if it's 25 degrees Celsius, like the intake temperature in the evaporator, Like how long? Like it will take more time heating or what? Like this is one of our questions.
So see, typically heat pumps operate between 0 to 45 degrees. Okay.
Okay.
And the higher the temperature, better the COP. Okay. This is the thumb rule of any heat pump systems. But however, higher the temperature, practicality wise, higher the temperature means people wouldn't need hot water, right? I mean, already the water will be hot. So in terms of COP itself, a good COP will be between 25 to 35 degrees, between 20 to 35 degrees. Let's say.
Okay. So do you have any like information or catalog? Normally, air conditioning we used to give this kind of information. For the each region, we have like what will be the temperature or kilowatt. Like, but if you have some documents highlighting like if it's 25 degrees Celsius, what will be the output or how long it will take to heat the water heater, like heat pump. So is there any documents or?
We can provide you that. We can provide you such details. Yes.
No problem. Okay. We'll contact you.
All right.
For this information. Thank you.
So for everyone, I have put out my details on the screen. You can note down my email address as well as my mobile number. In case you have any questions, anything to do with the heat pumps, you can reach out to me. You can text me. I will be happy to support you with that. Because we are running out of time, I cannot take any more questions. So I would like to thank you all for taking your time to come and join this meeting, and I hope you took something of value out of this meeting. And please don't forget, next week we have an advanced training on the heat pump selection itself, so we can discuss further in that podium. Thank you, everyone.
Thank you so
Please
much.
share with us the presentation if possible, please.
Sure.
Acquisition.